Hello all. So this is for the third packet of notes, the annuities. We're going to be working on savings annuities and payout annuities. So in the previous section, we talked about how you might save money for your college tuition. And you found that if you have a lump sum of about $32,000 and you put it into a compound interest, you would have enough money. Well, that's not always feasible. So instead, what we might want to do is something called a savings annuity. And what an annuity is you're putting in money every single month or period and saving over time. So instead of having a lump sum with simple interest or compound interest, you're continually putting money in it. So you might be putting $100 a month into a college savings plan, or you might be doing $5 a week, or you might be doing $30 a quarter. All of those are varying K values. So most of your retirement plans, IRA accounts, the 529s for college, those are all what we call savings annuities. So the idea behind them is you're trying to build up some large amount, but saving in equal increments over time. So to start, N is what it was before. It's still your time. And in this case, it's the number of years that you're saving. That relates to K because K is the number of compounding periods in 1 year. So some common ones are if you're going to do monthly, your K would be 12. If you were going to do quarterly, your K would be 4, semi-annually would be 2, etc. All right. So then we have a couple other variables here. So your PN is now the amount in the account after N years. So if you're saving up for something, it's that total amount that you're then going to draw from. D is your deposit amount, and that's a recurring deposit. So you're not just doing this one time, you're doing it recurringly. And then we have a note here, if the compounding frequency is not made explicit, assume it's the number of deposits you make. So if you're making monthly deposits, we're going to assume we're doing monthly compounds as well. And then finally, R is your annual interest rate. And just make sure to note, we always do decimal for this, or it'll give you something very interesting. And then we have our overall formula. You do not have to memorize the formula. You're going to be given the formula sheet. My note with this is make sure you're watching to make sure all the parentheses are in the right spot. And then I would work it little by little versus trying to punch it all in the calculator. Sorry about that. Okay, I am going to clear my screen and keep going with the first example. So if you need what's on here, you might want to go ahead and pause me. So here is example 1. So we're trying to deposit $200 each month into a savings account. So that deposit being $200 and the fact that it's monthly tells me that that's an annuity versus just a regular savings account because we have recurring deposits, meaning we're doing it every month, and that each month tells me my K value that it's 12. My R value is that 3%. 3 divided by 100 is 0.03. And then again, we're compounded monthly, so K is 12. So if we're doing our formula, our formula is for a savings annuity. And we're going to grab that formula up top. So you just want to figure out which formula you're supposed to use. This is a savings annuity because I'm trying to save and have money in that account after 30 years. And I'm using a recurring deposit every month, so it's an annuity. So for A, I've got all our information in here. We're going to put all the information into that formula. So I've got it written over here. Oop, our deposit is $200 a month. Sorry about that. So we are trying to look for 30 years from now, how much is going to be in there. So for that, I'm going to do P of 30, representing the amount in the account after 30 years. And then I'm going to follow closely with all the parentheses exactly as they're written on that formula sheet. So this was the deposit, 1 plus the interest rate over compounds, and then number of years times number of compounding periods, because you're putting those in 30 times 12, all that minus 1, and then all divided by your 0.03 divided by 12. Hopefully you're writing a little smaller because I'm going to have to delete this. So if I put all that in, I'm going to come up with an answer of about $116,547.38. So you might want to pause it if you need to write this down because I'm about to clear the screen. Okay. So on the calculator, what this would look like is you would put a parenthesis and then do your 200, double parentheses, so exactly how I wrote it, 1 plus 0.03 divided by 12, caret button, 30 times 12 in parentheses, minus 1, close, close, and then keep going, division, 0.03 divided by 12. Make sure you have all of those parentheses there. And then practice this a little bit to see if you can get it to work. So we end up getting $116,547.38. I rounded to 2 because it's money. And make sure to try this on the calculator because you absolutely need to be able to get this exact answer. So that was part A. For part B, it says, how much total money will you put into the account? So think about this. You're going to be putting in $200 every month, and there's 12 months in a year, for 30 years total. So I'm going to be putting in 200 times my number of months times the number of years. And if I multiply those together, I've put in $72,000 over 30 years, and I'm getting out $116,547.38. That's not bad. Right, I'm about to clear the screen. So for part C, how much total interest would you earn? Think about this. If you are getting out $116,547.38 and you put in $72,000, the difference is your interest. So it's your PN, your total amount, minus amount you paid. And if you put that in, you are earning a total of $44,547.38 in interest. So not bad for a savings plan. Okay, so again, focus on, can I get those answers out of the calculator? How am I setting it up, etc. So our next one now is we want to have $800,000 for retirement in 30 years, and the account is earning 6% interest. So when we're asked now, how much are we going to deposit each month? Because we want to deposit monthly, that's a recurring deposit. This is a savings annuity. I'm trying to save up for retirement. Okay. So for part A, we're going to use that savings annuity problem, but we've got to figure out what everything is. So I'm going to write up here just to give me a little bit more space. His value that he wants in the account at the end is $800,000. So note that's PN, that's not your D, that's PN. it says that we want 30 years. Our account is earning 6% interest, and we are depositing monthly. So I've got all that good information up there. So to put that into my formula, I'm going to have 800,000 equals, this time I don't know D. So I'm going to do 1 plus my 0.06 divided by 12, raised to my 30 times 12 minus 1, all over 0.06 divided by 12. All right, so look at this algebraically for a second. Now, you did a little bit of algebra work in the last section, but if we're trying to get D, D is being multiplied by the stuff beside it and divided by what's under it. So it would make sense to multiply this together. So I would do 800,000 times that 0.06 divided by 12. And then since D is being multiplied, we actually divide by that whole piece. So just write exactly what it is here, 1 plus 0.06 divided by 12, 30 times 12 minus 1. And that equals your D algebraically. So what that looks like in the calculator is you're going to do 800,000. I'm putting parentheses around the whole top portion too, times 0.06 divided by 12. So all that piece up here is right there. Okay, and then we're going to hit divide by that whole bottom piece. So 1 plus 0.06 divided by 12. Sorry, I'm running out of room here. Caret 30 times 12 minus 1, close parenthesis. So it's exactly what I had up there. All right, you might want to go ahead and pause that while you write it down, because I'm about to clear the screen. Okay. So how much do I need to deposit each month? Your D should turn out to be $796.40 is what you deposit each month. So if you do that at that interest rate for 30 years, you will come out with that $800,000. So then the next question is, how much have you actually put into the account? So that's how much you put in times the frequency. You're putting it in for 12 months a year times that 30 years. So again, the amount you're paying per month times the number of months times the number of years. And that amount ends up being $286,706. Okay, and here's the really good part. How much interest did you earn? You ended up earning the amount that was in the account at the end, which was $800,000, minus the amount you paid in, which is $286,704. So quite a lot of money here. You end up making $512, sorry, and 296 $296 earned in interest. Not a bad gig. Almost tripling your money. Okay. All right. Okay, so that is your savings annuity idea. So again, you know you have a savings annuity if you're trying to save up for some amount and then you're putting in deposits every month. Right? If you are still writing, pause me because I'm going to clear my screen. Okay. So our next one is called a payout annuity. So it's very similar to the other one. Formula is similar, a little bit different. The idea with this one is now you're taking regular withdrawals. Okay. And think of this, if you won the lottery, you might want to take that lump sum, put it into a payout annuity, and then have it pay you out every month, so you always have a little bit of money coming in. Another one would be, once you save all your money for retirement, you've got that 401k, you then want to figure out how much you can actually take out every month or every week or every year, depending on how long you want to try to have it. Now, the good part about a payout annuity is you're still earning interest on the money you left in. So it makes your money last a little longer than just taking it out as a lump sum, 800,000 when you're done, because you're still earning interest the entire time. So formula for this one, all the variables still mean the same thing, but we now have this idea of a PO versus a PN, but they're still really similar. PO is the beginning balance. Okay, or the initial amount at the time of the retire or the lottery win. So it's your initial amount. Okay. And then the others are the same they were before. N is your number of years. D is your regular withdrawals versus deposits. This is the amount you're taking out every time. And again, it's a payout annuity because you're taking out some type of whether regular withdrawal, usually monthly, but it depends. R is still your annual interest rate. And again, that's a decimal. And K is your compounding periods in a year. Okay, so you still have the same idea as before. If the compounding frequency is not made explicit, assume it's the same number of withdrawals. So if you're withdrawing monthly, you're compounding monthly as well. Okay, I'm going to clear the screen, so pause me if you need to. Okay, so I've got this example down here. We have 500,000 we saved for retirement. So just to use the space up here, 500,000 would be my PO. Okay, account earns 6% interest, so that would be up there. And how much can I pull out each month if I want to withdraw? If I want to withdraw for 20 years, and my K is monthly. So I am looking for how much I can withdraw every month for this first part. So if I put all that information into the formula, I get 500,000 equals D, I don't know, 1 minus 1 plus. Oh, this is not going to fit. Uh-oh. Okay, I'll move it back down here. So I get 500,000 equals D 1 minus 1 plus R over K negative N times K all over 0.06 divided by 12. Same idea here as before. We're going to multiply these together and then divide by this component. Okay. So if I do that, then I get D equals that 500,000. And again, that's multiplying these together times 0.06 divided by 12. So that's multiplying this component and then dividing by all of this piece. So I divide by 1 minus 1 plus 0.06 divided by 12 raised to the negative 20 times 12. And you can't really over parentheses, so don't worry about that. And then if that's not giving you the right answer, try doing just the top part first. Oops, sorry about that. Try doing just the top part and then doing the second part separately and dividing, and then don't round until the very end. Okay. So down here, my answer for A, when I do all of that math, is that you will get monthly withdrawals of $3,582.16. And while you're withdrawing, the money that's staying in is also earning interest as well. If you want to type this into the calculator, it looks like this, parenthesis 500,000. Oops, times 0.06 divided by 12, divided by parenthesis, 1 minus 1 plus. Make sure those parentheses are in the same spot. They should not cancel out each other. Raise 2 with a caret, negative 20 times 12, close. Okay, make sure right here you use a negative sign and not the subtraction, or it'll get you an error. That's an actual negative sign because we're trying to withdraw as we go. All right, pause me because I'm about to clear. Okay, so for part A, we have that we're going to get to withdraw $3,582.16 monthly using this retirement plan. Okay, part B says how much money will you actually withdraw? So if I'm withdrawing $3,582.16 every month for 20 years, okay, so amount times the month times the year, that's going to give me that amount that I'm getting out total, which is a very nice number, $859,718.40. So you had $500,000 that you were drawing off of, but because you're still earning interest on that money as you withdraw, you get a whole lot more money. And then C now says how much was interest. It's going to be the difference, the $859,718.40 minus your $500,000 you started with. And you end up getting about $359,718.40. So if that was a lump sum from a lottery earning or some type of game show, if you put it in this annuity, you still get a nice $3,500 every month, and you continue to earn interest as you go. That might not be a bad idea. All right, I am clearing the screen and moving on. Okay. All right, now we have, we're trying to determine if we want to make payouts for 30 years, and we know that we need to withdraw about $3,500 each month to live comfortably. How much do we need to have in the account in order to do that? So the question would be, what are we being asked for? So if I'm not sure, I just start listing all my variables out. So I know it's a payout annuity because I'm trying to get monthly withdrawals. So I'm paying myself over time with those regular withdrawals. So let's start to list what we have. We want $3,500 a month. So that's my D. We want to do it for 30 years. I've got a nice 7% interest rate. And let's see, what else do we have? We have compounded monthly. So the only piece we're missing now is that PO. We need to know how much is in the account at the start to make this happen. So if we do our PO formula, now we can do a direct one. We don't have to solve the algebra. It's 3,500 times 1 minus 1 plus 0.07 divided by 12, negative 30 times 12 double parentheses, all divided by 0.07 divided by 12, and that'll end up getting you your answer. So as I mentioned before, it might be helpful to do this in pieces. So do the entire top and then the entire bottom, and then divide the two, and just don't round anything until the end. And then because these are all money, these are all being rounded to 2 places. So when I'm done, I end up showing that I would need $526,076.44 in the account when I started. So when you get to the lottery problem on the homework, you can figure it out by doing a savings and a payout. So if you're trying to pay out a certain amount, you figure out how much you needed and then go back and figure out how to save. So the lottery problem is a payout annuity and then a savings annuity. It's a 2-part one. So in terms of when you should use what? Compound interest, simple interest, is one deposit, one time, that then keeps earning interest, but it's just one amount. Annuities are if you have many deposits. And then payout annuities are when you have many withdrawals. So again, the main word there is many. You're doing more than one. And then what we're going to talk about next is this idea of a loan, which is where you're making many payments. So in terms of looking ahead, you are now good to go with homework number 1 and 2. And then 3 will be loans and 4 is a nice review. And if you're in my class, you're also good to go with quiz 1, which is quiz 6, and quiz 7. All right, have a great day.